Welcome to the Crazy Hat Chemist. So we're doing another Lewis dot structure today. So let's get started. Bam! So drawing Lewis dot structures, number 7. Today we're going to draw the Lewis dot structure of phosphorus pentachloride. So the first thing that we need to do is get the formula for phosphorus pentachloride. If you look at those two elements there, these are two nonmetals. So if you go back to your nomenclature videos, and I hope you do, that is two nonmetals. It's a binary nonmetal compound, and it's using prefixes. So it's phosphorus pentachloride. So phosphorus, there's only one phosphorus, and penta, that's for 5, and that's 5 chlorine. So it's PCl5. All right. Now the next thing we need to do is we need to look at our periodic table and determine the number of valence electrons in each element, and the number of elements in there, and then total up the valence electrons. So phosphorus is in group 5, that's 5 valence electrons. Chlorine is in group 7, that's 7 valence electrons. There's only one phosphorus, but there are a total of 7 chlorines. So we're going to multiply that there's a total of 5 chlorines. So we're going to multiply that 7 valence electrons times 5. We're going to sum these numbers up, and then we will get 40 total electrons. We're going to divide everything by 2, just like what we've done in all the previous Lewis dot structures, so that now we get pairs of electrons. So that gives me 20 pairs of electrons. Next thing we need to do is we need to, again, refer back to our periodic table and figure out which is the least electronegative element. The least electronegative element goes in the center. That is the element that is furthest from fluorine. So, phosphorus is farther from fluorine than chlorine is. Chlorine is the third most electronegative element. So phosphorus is going to go in the middle because it's the least electronegative of the two, between the phosphorus and the chlorine. Then the chlorines are going to go surrounding the phosphorus. Now, here's a key structure here, point. Now, all the other problems that we have done, we've put the other elements around in an X marks the spot pattern around the central element. This time, we actually have more than we can put around the X marks the spot. But phosphorus is in period 3. That means it can exceed the octet rule. Also, chlorine, there are 5 of them. So we're going to equally distribute the 5 chlorines around the phosphorus. Here we go with that. So phosphorus is hypervalent. It can exceed the octet rule because it is period 3 and above. And I want to make a clarification here. It is not period 3 and above physically on the periodic table. It is period 3, period 4, period 5, period 6, period 7. That is period 3 or greater in period number, not physically above in the periodic table. That's a fine distinction, but it's very critical. So the next thing that we're going to do is we're going to look at our 20 pairs of electrons, and we're going to displace them around the central element and the outside elements as sigma or single bonds using a pair of electrons. I've done that just there right now. The next thing we do is, the next rule is place lone pairs of electrons around the outside elements. And that's what we've done right there. Now what we're going to do, we have used up all our 20 pairs of electrons, or total of 40 electrons. Now we're going to circle each element. I've circled each of the chlorines, and each of the chlorines has an octet. They must have an octet, so that's looking pretty good. And I circled the phosphorus right here, and it actually has 2 more electrons than what it supposedly could have. And therefore, it is period 3 and greater. Therefore, it is hypervalent and can exceed the octet rule. Now, the next thing that we need to do to complete this Lewis dot structure is we need to change those dots between the central element and the outside elements to lines, but yet keeping the dots as lone pairs of electrons around the central element there. And that is that I will get this structure right here. That is phosphorus pentachloride's Lewis dot structure. I hope you enjoyed that video. I am the Crazy Hat Chemist. This is going to be the next video in the series, drawing another Lewis dot structure. I hope you don't take offense to any of my hats. I know some of them are culturally sensitive, but many of them I get from my former students. So I want to thank all of my former students for providing me such really cool hats. So give me a thumbs up on that video, subscribe to my YouTube channel, and I will see you next time for more chemistry. Bye now.